Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to look at one of the applications of integration. Okay, what we call the trapezium rule. This is Mr. Hackman of Omega Education Consults, your facilitator for core and elective math. Please stick and stay with me whilst I take you through today's lesson. Okay, so just as you can see on your screen, we are going to deal with the trapezium rule. So the main objective for today's meeting will be by the end of the lesson, the student should be able to appreciate the concepts behind the trapezium rule. So understand the trapezium rule and its associated concepts. Okay, that is the general objective. However, the specific objectives will be, okay, the student should be able to quote the trapezium rule, okay, and apply the trapezium rule. Okay, so quote and apply the trapezium rule under certain conditions. Okay, so quickly, okay, so you can see this is the trapezium rule. Okay, at the normal circumstance, we will prove, okay, or we are supposed to prove, but I won't bore you with the proof unless it becomes very necessary. Okay, so what we have here is the rule. And the trapezium rule usually is used to find the area bounded by a curve, okay, and the x-axis between, okay, two, okay, limits or a certain interval. Okay, however, this particular rule will give you an approximated value, not the exact value in terms of what's the area. So that's the more reason why you can see that here we have the integral from a to b of y dx. Anytime, please take it. Anytime you are integrating any function with respect towards x, indirectly you are finding the area. Indirectly you are finding the area, so take note of that. So the integral, okay, like I said, from a to b of your function, which is y dx, okay, by the trapezium rule, this is the trapezium rule, will be approximately equal to, so equivalent to, it will not be exactly equal to, please take note, it's an approximated value in terms of the area, like I stated, will be h, okay, over 2, okay, then you have y sub 1 in bracket, square brackets, y sub 1 plus y sub n. So what you do is you sum your first, okay, y value and your last y values. Okay, then plus twice, okay, the product of what? The sum of all the other y values between your first and what? And the last y values. So, and that we know that from y sub 1, you go to y sub 2, you go to y sub 3, up to, and before y sub n, there should be y sub n minus 1. So these y's that you have here are the y's between your first y, the y subs are the y's between your first y and your last y. Okay, that is y sub 1 and y sub n. Okay, and going forward, if it becomes very necessary, I will let you know why this situation, why the first y and the last y, you have it, okay, only once. You sum them, okay, then the others will be twice. So that's the more reason why you have two outs. Okay, so where in this case your h, okay, will be equal to the h obviously is height, okay, will be equal to what? B minus a, which is the upper limit of your integration minus the lower limit, what we call the ordinate. So the lower ordinate and the upper ordinate. So the upper ordinate minus the lower ordinate over n minus 1. So if you quote if you quote your h this way, then your n that you have here, I've told you that the a and b already you know. Okay, the a and b will be your limit of integration. The upper limit, the lower limit. And the n here will be the number of ordinates. So if you quote your, your h this way, okay, then it means, okay, the n is for or representing the number of ordinates. And I will let you know, okay, what we mean by, okay, the number of ordinates very soon. Or h will be equal to b minus a over n. So if you quote your h this way, then it means your n that you have there is what's representing the number of what strips. Okay, by that, this is what we have here. Okay, so let me see. So this is it. At the normal circumstance, okay, anytime you are integrating or you are finding the area bounded by a curve, okay, and the x-axis, this is your curve. Let me at least see if I can, okay, pick a pen. Okay, the pen here usually it doesn't. Okay, so let me. So this is your curve y. Okay, which is the same as what? F of x, remember. Okay, and my curve, I'm finding the area bounded by this curve. I can extend this curve. Okay, I can extend this one as well. Okay, so if I'm finding the area bounded by this curve and the x-axis, you can see that the curve and the x-axis, obviously you don't have a finite region. Okay, if I draw something like this, I have my x-axis and I have my curve this way. Okay, am I able to find the area bounded by the x-axis and your curve? Obviously no, because area, your region must be finite. The curve and this, you don't have a finite region. So usually will restrict you. So that's the more reason why we'll give you the boundary in terms of the ordinates. So immediately these two lines are introduced, then it means your region here is bounded by the curve and the x-axis between these two what limits. So in that case, you can find the area because the area will be a finite region, and every finite region we can find its what area. Every bounded region we can find its area. Okay, so indirectly we are looking at the proof. I said we wouldn't do that anyway, but I just want you to use, okay, the diagram that we have here, okay, for you to know the distinction between the ordinate, the number of ordinates, okay, and the number of strips, your strips and what, and ordinate. The ordinates will be the lines that you use in dividing, okay, what do you call it, your region here, the area here, okay, into, okay, equal heights. So in this case, let's say this will be my A, my first value of the X, and this will be my B. So it means I'm finding the area bounded by the curve, the x-axis from A towards B. That will be my limit. Because you are integrating with respect to x, it means your limit must also be in terms of x. So the A here will be x value, your B here will also be a certain x value. Your first S value, your last S value. Please take note. Okay, so here, okay, so if you are talking about your ordinate, your ordinate, remember I said will be the line. So it means here this will be my first ordinate. So x sub 1. Okay, my second ordinate S sub 2, my third ordinate S sub 3, my fourth ordinate S sub 4, okay, X sub 5, okay, S sub 6, and this one will give me S sub 7. So if I have this, I can see that here, if I count, I'm looking at 7, okay, ordinates. However, if you are talking about the strips, okay, this will be one strip, 1. This will be 2. This, you know that the strips will be from here to here. The whole of this will be regarded as a strip. You agree with me, right? You know what a strip is. Okay, so then this will be 3, 4, 5, or 6. So you can see that if you look at your number of strips, okay, your number of ordinates is always one more than the number of strips. Your number of strips here will be 6. However, the number of ordinates, okay, is what, 7. So obviously, there is a particular relationship between your number of ordinates and your number of strips. Okay, take note. Your number of strips will always be one more than your number of what or ordinates. So indirectly, I can say that my number of strips. Okay, so sorry, my number of ordinates. Forgive me, ordinates. Okay, will be equal to, okay, number of strips. Let me use number. Okay, short of strips. Okay, plus what? 1. Okay, my handwriting is not that legible. Okay, I've told you that usually when you pick the, what do you call it, the pen from here, okay, becomes, okay, the handwriting doesn't really, okay, look nice. So all that you need to know is that the number of ordinates will be equal to your number of strips, okay, plus 1. So therefore, your number of strips will be equal to the number of ordinates minus 1. So you know the relationship. Once you know this, any question, okay, given in terms of the trapezium rule, with an additional information that will be given to you, you should be able to deal with it. Okay, so quickly, any question before I move on to our next slide? Okay, at normal circumstances, like I said, okay, we could have, or we were supposed to prove the trapezium rule, But you know, I've told you we have a limited time today. So I'm not going to take you through the proof. You have the internet access to the internet. Okay, go and check the proof. Okay, all right. So, and let me go back and tell you something there. Maybe what equally you will see in books. So when you see that in books, don't be confused. It's basically the same thing. Okay, in books and even in your four-figure table. Okay, let me see. Okay, let me change the, okay, all right, forgive me. I will go back. Okay, instead of y sub 1, they start from y sub 0. So it will be y sub 0, okay, plus y sub n. Your last one will always be n. Then, so if it means if this is y sub 0, then your y's here will start from y1, y2, because in between from 0, you move on to 1, 2, 3, what have you. But because mine is starting from 1, in between, you know you are going to get, let me see if I can get it, pick. If I'm looking at my y's, okay, I'm going to get y1, y2, y sub 2, y sub 3, okay, up to what? Y sub n. Okay, so if I start from y sub 1, it means in between, okay, before the y sub n will be y sub n minus 1. So in between, the y's will be this. Okay, and that will be the outside y. So you sum the extreme y's, which will be the first y and the last y, like I explained. Then now what do? It will be plus twice the sum of what? Okay, the other y's in between, okay, the extreme what y's. However, if I start from y0, then I have to move to y sub 1, y sub 2, okay, your ellipsis, okay, before y sub n will be y sub n minus 1, okay, then y sub n. So with this one, my extreme y's will be y sub 0, y sub n, and my in-between y's will be y sub 1 up to what? Y sub what? N minus 1. So if you see, okay, in books this way, this one, okay, please don't be confused, the same thing. Okay, is the same thing. You should know that your first y and your last y, okay, you will come and sum them together. Okay, that one will not be multiplied by 2. But the rest of the y's, it will be twice the sum of what the rest of the y's. Okay, so quickly, I've explained what is meant by number of ordinates, number of what strips. So if you know your number of ordinates, then you quote this one to get your h. If you know your number of strips, the question gives you your number of strips, then you quote this one to get what? Your h. However, if you are matured, you can only learn the first one in terms of the number of ordinates if you know the relationship between the ordinates and what? And the strips. So if let's say the question gives you strips and you quote this, okay, you should know that, okay, the number of what ordinates will give you your number of strips plus 1. So you come and substitute, okay, the plus 1, and that will take you back to what you have here. Okay, so quickly, let's go and look at an example. Okay, all right, so let me clear this. Then we look at an example. It's nothing difficult. You just have to, it's calculator work. Get the formula, know what the formula demands, and you are good to go. All right, so let's look at, okay, our first question. So this is our first worked example. Okay, using trapezium rule, find correct to the nearest. Okay, so let me underline the salient part so you know there is an approximation. Find correct to the nearest integer. The value of integral or integration from half towards 3 of what? 1 over x plus 2 dx at x is equal to 1 over 2. So you've been given certain x words values. Okay, here. And now let's go and look at what the solution. Okay, so solution, as usual, when immediately, I think, let me see if I can close this. So immediately, okay, you read the question, underline the salient part. The first thing that you write is solution. Okay, then your question number. Okay, then after that, what do? You extract. So this is what you will need. This you can choose not to extract, okay, because the table will bring out this information. You will construct. So after that, then because this involves a formula, quote the formula and let the formula guide you. So this is it. By the trapezium rule, okay, you quote the trapezium rule. And as you mature, you can choose not to write it, just like the first principle. Because the principle, the rule, the theorem is not named after a person. Okay, you can straight away quote it by writing but, then you quote it. Okay, but you quote it. So when going forward, that's what I will do. So by the trapezium rule, you quote it. Okay, the integral of this, okay, is equal to, once you quote the trapezium rule, let the rule talk to you. Okay, so the trapezium rule, I need my A and B. Do I know? Yes, the A and B is given in the question. So you know your A and B. So A is what? Half, a B is what? 3. Okay, then if you compare, your Y is what? 1 over S plus 2 here. So that will be your Y. Take note. Then it's equal to H over 2. Okay, and your H, let me see if I can go back a little. Your H usually will be, okay, the height. That's the distance between your ordinates. Okay, the height of what? Your equal strips. Okay, so that is what we are supposed to. So your height, and when the S values are given, okay, you can easily get your height, because the height will be the difference between, okay, the consecutive X words terms, and they will give you a common difference. So you just have to do, okay, the difference between. So it's just like you move from half to 1. So the gap there is what? Was 0.5, which is half. So that becomes your height. Is my point well made, my professors?
Yes, please.
Okay, so you know your height. When the X values are given, you don't struggle to know your height. Okay, so once I know my height, it means I need to start from X. So you always build a table. Okay, because you need to generate Y values. Remember, in the formula, you have Y values, Y sub 1 up to what? Your last Y value. And you can get the Y knowing what's the X, because it is the X that you feed the Y, okay, to get its corresponding value. So in this case, we are going to, remember we said when you compared, Y is equal to 1 over S plus 2. Okay, and X is starting from 0.5 to 1, and don't use fractions. Okay, always, okay, use the decimal representation in terms of your table. Okay, so this is 0.5 to 1 to 1.5 to 2, 2.5 to 3. So you start from 0.5 and end at what? 3, which is the same as start from half and end at 3. So now all that we need to go and do is to use our calculator, okay, to find the Y, the corresponding Y values here. So it means this is supposed to be your first Y value and your last Y value. And in between them will be the Y, okay, that will be here, as simple as that. So Y sub 1 will be here. Y sub what? Here it is 1, 2, 3, 4, 5, 6. So Y sub 6. So your Y sub n will be Y sub 6 here. Okay, and your in between will start from Y sub 2 up to Y sub 5. As simple as that. So it's just a formula way. So quickly, let's see what we can do. Okay, let me go, and usually when I'm working here, I'm not too, okay, because of the nature of. So let me see if I can take you to the normal view. Okay, so let's go the normal view, then see, okay, what quickly. Okay, so I think here will be better. Let me move this. Oops. Okay. I want it to be a little bigger. Okay, so this is what we have. So the normal view, so here we are going to find the X values and sorry, the Y values and write it there. So you know that the way this one you can even do it mentally, but I'm going to teach you how to use your calculator to generate, okay, your values, okay, straight away, so that you don't have to come and do substitute. X is equal to 0.5, so that will give you 1 over 0.5 plus what 2, so it will be 1 over 2.5. Then you use your calculator or you do it mentally, but usually I would advise you use your calculator to save time. Okay, all right, so this is it. Okay, let's go to our calculator. Let's pick our calculators. Okay, then go to mode, and you should have the table mode. So let's go to the table mode, which is mode 7. If you are using, okay, Casio FX 991ES plus, okay, then you should be in sync with me. Are we there?
Yes.
Okay, so when you press mode 7, which is the one that will give you table, you will see that immediately you press mode 7, it will give you f of x is equal to. So you will see this. Okay, f of x is equal to on your screen. Let me go to the other view, and I think you should be able to. Here it looks very small for me. Okay, I don't know whether it's because of my age. Okay, so you can still relate. Anything that I will write, I will say it. So you should know what I'm talking about. So once you have that, okay, this is what we are going to do. You need to feed the calculator, okay, with your function. The function here is the same as your y, and that will be 1 over x. So you press the fraction key. Okay, then you press 1, okay, for the numerator, and x plus 2, you know you need x, and x is an alphabet. So you press the alpha key, the key beside the shift key. That is to the right of what? The shift key. Are you there?
Yes,
That
please.
is
Yes.
then you press alpha. Alpha is on top of the bracket close key. Sorry, the x is on top of the bracket close key. You need x, so you press alpha. We've already pressed alpha, so you press the bracket close key. So you see s there. Is that clear?
Yes, please.
Then plus, okay, it's plus 2, so plus 2. So now this is your function. After you fed your calculator with that function, you press equal to. After pressing equal to, you will see start. So which s value do you want to start, okay, to find its corresponding y? And our first s value is 0.5. Is that clear?
Yes,
My
please.
professors, are you with me?
Yes, sir.
Yes, please.
Okay, so I will go back. Okay, I'm going back, see, but I'll go back. Okay, very. So I said, take your calculator on it, obviously. Okay, then after that, okay, you go to mode. You press the mode key. Then after pressing the mode key, okay, we are looking for the table, how to construct a table, get certain table values. So that will be mode 7. So that is per my calculator. Okay, per your calculator, look at the number, okay, assigned to that table, then press that number. So I will press 7 because 7 is the one that corresponds to the table. Then after that, immediately I press what? The 7. You will see f of x is equal to on your screen. So f of x is the same as your y. So you are going to feed your calculator with what? Your y. And your y, we said, is 1 over s plus 2. So 1 over s plus 2 is a fraction. So you press the fraction key, and the numerator, okay, you know, you fill it with 1. So you press 1. Then come to the denominator. The denominator is s plus 2. X is an alphabet. So you press the alpha key beside the shift key. Then you press the x. X is on top of what? The bracket close. So you press the bracket close key, and that will give you your x. Then plus what? 2. So at this point, you should have this on your screen. Okay, 1 over x plus 2. Is that clear?
Yes,
Then
please.
I said after that, then you press equal to. If you press equal to, your calculator will ask you start with a question mark. So which s value do you want to start with? And our first s value here is 0.5. So you press 0.5 and press equal to. It will ask you end. Which value do you want to end with? And the end s value is 3. You press 3, then you press equal to. Are we there?
Yes,
When you
Yes,
press
please.
that, it will ask you of the step. The step will be the same as what the height. Okay, from this you move to this, from this you move to so the step here, the difference will be the step, the height. Okay, and that will also be 0.5. Do you agree?
yes,
Yes,
please.
Okay, so you press 0.5. Are we there? Then press equal to.
yes,
You will see your table there. So your first s value, okay, will give you f of x, which is y, to be 0.4. So I'm going to write 0.4. All correct.
yes.
Okay, so when x is equal to 1, y is equal to 0.333. Is that not it? All correct.
Yeah.
Okay, when it is 1.5, it is 0.28 57. Are we there? Okay, Prof. Ella.
So can you only use this for like integration? Can you use
No,
it
you
for
can
like
use it for
normal table?
graphs of relation
Oh,
as well.
okay. 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 Thank you.
Okay. All right. I didn't teach you graphs of relation, right?
I don't think so.
Yes, I think so. I didn't. Okay, so you can prompt me. I can send you a video on that because usually I will guide you as to how to use the table to do that. Okay, then let's move on to the next one. Okay, so the next one, 2 will give us 0.25. Are you there?
Yes, please.
Okay, the next one will give us 0.222. Okay, so you can see that all the approximation there, which will be the one that will be more than 4, you can see that your table is having it in 4dp. That's the more reason why I always advise you to take your approximation to 4dp if it is more than 4dp. You get it? Okay, and the last one is 0.2. Is that okay?
Yes, please.
Okay, so at this point, we are in a comfortable lead. Okay, so this is what we are going to do. So so I can comfortably go and say that therefore, okay, the integral from what half, okay, to 3 of my y, and my y is 1 over, so what I was asked to find, x plus 2 dx, okay, will be approximately equal to. Your first one should take the approximate. After that, you use equal to, just like what I taught you in one of the topics. Okay, okay. Anyway, let's move on. So your h is 0.5. Do you agree? All over your 2. Then in brackets, your y sub 1 is this first y, 0.4. Okay, plus y sub n is the last y, 0.2. I hope you are following my professors.
Yes, please.
Then plus, okay, twice, okay, so 2 in brackets, your other y values in between you sum. So your first one is what? 0 point what? 3, okay, 333. Plus your next one is 0.28, okay, 57. The next one will give us 0.25. Okay, then the next one will give us plus 0 point what? 2222. You are done. You close this one, then you close the square bracket. All correct. My professors, are you with me? Okay, all
Yes,
right.
please.
Prof. Amma.
Sir, please come again
Okay,
with
so I said, with what?
the substitution.
Okay, so the substitution, remember, okay, we said in the formula, our first y and the last y. The last y is y sub n. So we are h is what? We said h will be the height. The height is the same as the step, okay, which is the same as the difference. From one point, the next value of x, okay, the difference, okay, your jumps will be the height. I hope you are with me.
Yes,
Okay,
please.
so that gave us the 0.5 then over 2. So the rest is just substitution. Remember in the formula, it said this is y sub 1. Okay, y sub 2, y sub 3, y sub 4, y sub 5, then y sub 6. Okay, which is the same as our y sub n. Your last y will be your y sub n. Your first y sub 1. Okay, so that's why I usually want to use y sub 1 instead of y sub 0. Okay, so in this case, you just substitute your first y, okay, which is 0.4, plus your last y from the formula, which is 0.2, then plus 2 the y's in between. Okay, so twice the y's in between. So y sub 2, y sub 2, 3, 4, 5. Okay, then that will be it. You've taken care of the first y and the last y. So the rest of the y's, okay, also taken care of, but times 2. So this will be equal to, yes, I now remember the partial fraction. I told you when you write, after you've written the identity sign, okay, after that you can use equal to. This is approximately equal to this. However, this is equal to what I'm going to write. So let's go. All right, okay, so 0.5, let's do this. Then we come and deal with what we have in brackets. 0.5 over 2 will give us. Okay, after that, please, you have to go back to your normal, if you want to use your calculator, you have to go back to your normal, okay, mode. So 0.5 over 2 will give us Quickly, let's go.
0.25.
Okay, so I can write 0.25 here. Okay, then plus, okay, in brackets. Okay, I'm going to deal with what I have in brackets here first. So the brackets, inner brackets will not go now. So I'll still keep my, okay, outer. Then I'll come and I can sum this and that. So I'm going to have 0.4 plus 0.2, and that will give us 0.6. Is that clear? Then plus twice, okay, in brackets. So sum the whole of this for me. This plus this plus this plus this. I'm relying on someone. Okay, fastest hands. Okay, quickly. We shouldn't waste time on this. Okay, our time is almost up. Please hurry up. Oh, someone should give me the value quickly. This plus this plus this plus. The calculator work. It's in this chakra. You don't have to waste time on that.
1.0912.
Come again. Come again.
1.0912.
912. Okay, then you close it. Okay, so this will be equal to again 0. Hey, is it 0.25 times, not plus? Okay, please forgive me. No one had my attention drawn to that. Let me clear. Okay, so it's times. Okay, so you know it's supposed to be as times. So I'm going to do the right thing. Okay, going forward. Okay, all right. So times, so 0.25. Then this time round, I know my next step, I will multiply this and this, so the bracket here will go. So the outer bracket here will now take the shape of the normal bracket. So I'll get 0.6, then plus, okay, I multiply this and this. So I'm waiting for you. Give me the 2 times this.
2.1824.
2.18224.
124.
Okay, then you close it. So you are in a comfortable is 0.25. Okay, then you come and sum this. So I'm waiting for the sum. 0.6 plus 2.18. Okay, 24. Quickly.
2.7824.
78, 78224.
4.
Okay. All right. So at this point, you multiply, and that will be your final answer. But there is a required approximation, which we have underlined. So multiply this and give me your answer. This times this.
0.6956.
6956. Okay. But remember, we are asked to take this one to the nearest, okay, integer, and that will be 1. Okay, so you put in brackets nearest, indicate your approximation, nearest integer. Safa, all correct.
Yes, please.
Okay, so when the question comes this way, where your x values are given, your starting x and all the x values in between up to your terminal x, okay, the question is very, very easy. Okay, it's just straight away. You just quote your formula and apply your formula directly. So now let's go and look at our next, okay, one. So let me take the move on to the next. Oops, okay, if I don't clear it, that's the more reason why I usually. So please capture it. Okay, other than that, with this one, if you don't clear and you move on to the next page, it will be there. Okay, so capture it, okay, for me. Okay, maybe the notes I will type it so it will look, okay, better. Okay, all right. I wanted human touch. Other than that, I would have typed the whole of this, then walked you through the solution. Okay, all right. So if that's the case, then I have to clear the whole of that before we can have a clean access to. Okay, so the whole of, so let me clear. Okay. Okay. All right. So now I guess we can continue. Okay. So let's move on to the next one. All right. So let's look at this question. Okay, another question. So the questions, as usual, are carefully selected for you to know, okay, exactly how to maneuver your way around all the tricks. So use the trapezium rule with 6 ordinates. So here you've been given your number of ordinates. You underline that. To calculate, okay, it's basically the same question. Okay, put in a different form. Okay, so to calculate, okay, the integral from 0 to 5, 0.5 to 3 of what? 1 over x plus 2 dx, correct to the nearest integer. It's the same, okay, thing that we are going to do, okay, here basically. So I will only help you out to a point, give you the additional information. Then after that, the rest you should be able to, because it's the same question, okay, indirectly. And you will soon know that it's the same question. So this is it. You quote, okay, solution, question number, given this by the trapezium rule, or you can write but, then you move on to this. Okay, the difference between this one and the first one is that the first one, you know all your x, so you are easily, okay, you are able to get your h. Okay, but with this one, you don't know your x for you to find the difference. Okay, your first x and the next x for you to find what the difference that will give you a h. You only know your first x and the last x. You don't know two consecutive x values. You get my point?
No.
Should I come again, or my point is well made?
Please come again.
I should come again. Okay, so the first one, remember you were told that x will start from half. Okay, one and half. Okay, two and half,
Okay.
three. You get it?
Yes, please.
Okay, so for that one, because you know all your x values, where it starts and where it ends, and all of them, because you know two consecutive x value, we're able to find the difference, and that will be your h. But with this one, you only know your first x, which is your a, and your last x, which is what? 3, your b. Is that not it? But you don't know, you only know the first and last. So I know that I'm going to start my table from the first S value, which will also be 0.5, and the last S value, which will be what? 3. But in between, I don't know. So I don't know two consecutive S values for me to find the difference, and that will give me my H. You get the point? Directly. So with this one, you are supposed to go and find your H. And remember, we are told, also I can write but I know that my h, when I am given, oops, let me write it well. When I am given the number of ordinates, remember, will be equal to b minus a all over what? Over n minus 1. Do you remember the formula?
Yes, please.
Okay, so which will give us our h will be equal to, what is your b? Your b is 3. So it will be 3 minus your a, which is 0.5. Over your n. Your n in this case is your number of ordinates. What's your number of ordinates? 6. So that will give you 6 minus 1. Am I right?
Yes, please.
Okay. So which in effect, assuming this my next page, okay, I should have pushed this one down to create more room. Okay, or otherwise, this one basically is also you can write equal to, substitute and do it. But I always want you to avoid writing more than 1 equal to. Okay, so you wouldn't do this. You will do all this before you come to the table. I didn't leave enough room for, okay, the volume of work there. So at this point, what do? I am going to get 3 minus, so you can use your calculator to do this straight away. So what will be your H?
Half. Half.
This is 0.5, is that not it?
Yes, please.
Okay, so it then becomes the same question. So you start from 0.5, then you keep on adding 0.5. So you end at what? 3. So it is the same question put in another way. So this time around, you have to do a little more work before you can find your H. The other one, you can get your H easily, okay, by knowing, okay, your incremental jumps. Is my point well made?
Yes, please.
Okay,
A
so it
question.
means, let me land. So it means the solution from here will be the same as the previous one. From here, after getting your H, then you go and get your table, you know your X. So your first X value, you keep on adding your h, which is 0.5, so you get, then you come and find the values of y using your table, the way I helped you to get your table y values. Okay, then you go and continue in the same way. Okay, Professor. You said you have a question. Professor, are you there? Can you hear me? Okay, all right. So if that is okay, then we can move on to the next, okay, one. So let me clear this. Unfortunately, if I clear it and maybe the question, okay, maybe I'm hoping that I should still be able to answer a question without, okay, hey, what is this? Didn't I do? Okay. So I think that I should have picked the pen from here. The other one, too, instead of picking it from here. Okay, that was my mistake. Other than that, it could have been still there. Okay, forgive me. All right, so this is what we have. Okay, so now let's look at the third question. Find the approximate values, okay, for what we have here. In actual fact, it's supposed to be approximate value, okay, not values, because it will give us the same thing. Okay, I changed initially, this was 5. If this is 5, then it means they will give us, it will be, we are going to get different result, but I wanted, okay, the same result. Therefore, I changed this one to 4. So it's the same question in that way, put it differently. So find the approximate value, okay, for, okay, integral from 1 to 2 of 1 over s ds using the trapezium rule with A, 5 ordinates, then B, 4 strips. Okay, so as usual, the first thing that you write solution, question number given, you extract. Okay, you are finding this. Okay, and or quote your formula. Okay, so when you quote your formula, then we come to A, because this is the formula that you are going to use for A and B. If you come and write A here and you quote the formula at A, when you are doing the B, you have to quote the formula again. You get the point? So we are being smart. We've quoted the formula and we are going to take the formula as a general information. So A, I can use the formula. B, I can use it without. Okay, so I'll quote the formula once. So A, what are we giving? Giving number of ordinates n to be equal to 5. Okay, so I will need my h. Other than that, there is no way. I know that my x will start from 1 and end at 2, but I cannot get all my s values in between 1 and what and 2. So if I don't know my h, I wouldn't be able to do that. So when I'm giving the number of ordinates, I know that my h, okay, will be equal to, so I can write but, okay, h is equal to or even b minus a all over what? Over n minus 1. Or better still, you can choose not to quote the formula in letters. Okay, you can straight away move to this, but h is equal to, okay, then you come and write this. Okay, so that will give you, I will help you up to a point. So b, what is your b? B is 2. Minus a is 1. All over n is 5. Okay, minus 1. So that will give us what? 1 over 4, which is 0.25.
Very true.
Okay, so
Yes.
0.25. So now you know your age. So all that you are going to do is, like I said, I'll only help you up to a point. Because so come in, now you can now go for your table. Okay, so your table you draw. You cannot draw with your free hand, take note. So your first S value, so this will be your S values. Then Y. What will be Y this time round? Y will be equal to what? If you compare, what will be Y? If you compare this
One of it.
1 on X. Please, I hope you are with me. Okay, so again, your X will start from, okay, 1, then you keep on adding, okay, 0.25. So that will give you 1.25. You keep on adding till you get your last, okay, X value, which will be what? Which will be 2. Is my point well made?
Yes, please.
Okay, then after that, you use your calculator to generate the y values here. Find the y values. Okay, then go and write there for integral from what? Whatever 1 to 2 of 1 over x, okay, dx. Okay, will be approximately equal to then h, which is what, 0.25, okay, over 2, then into your first y value plus the last y value plus twice the other value, y values in between, you close it, and you are good to go. The rest will be calculator work. Afa, hello, is my point well made, my professors?
Yes,
Okay, very good. Okay, so any questions before I move on to B? Okay, so you've handled at least the second example under the situation where you are given the number of ordinates. Now we are going to look at the situation where you are given the number of strips. Okay, so if you are given, so let me squeeze that one here. Let me see whether I created a room for the next. Okay, so that's a different, I didn't create. Okay, so that will be B. So assuming, okay, this is what so B. Okay, given, okay, number of strips. Okay, I can equally call this one N. So number of strips, comma, N. And that is equal to 4. So here I know that my H will be equal to what? B minus A over N. So what is, so you can write it, or you can, like I said, straight away move. So B is 2 minus 1 over what? Over 4. Because if you are given your number of ordinates, remember, sorry, your number of strips, it is over N. If you are given your number of ordinates, it is N minus 1 in finding your H. You get it?
Yes, please.
Okay, which will equally give us what? 0.25. So it will follow suit from here. Okay, it will be the same. So it's the same question put in a different form. Okay, one, you've been given the number of ordinates, okay, and the other one, you've been given the number of strips. But if the number of ordinates, okay, is 5, then it means the corresponding number of strips will be what? 4. If the question gives you, so it means with this one, okay, what do you think, okay, the number of strips should be for this question to be the same? If you want to quote it using the strips, what do you think the number of strips should be?
Hmm.
The number of strips
Fine.
should be 5. Remember, your number of ordinates will always be 1 more than the number of strips. Okay, you know the relationship, so that's it. You are good to go. So this will be 8-4. And this question, okay, is a past question. That will be your assignment. I think it's Nigeria. I think it's Nigeria Wasi. Okay, this question. Okay, 2024. So you can equally try. Okay, if that is the case, that brings us to the end of, okay, today's, okay, lesson. Okay, maybe the entire vacation classes with respect to elective maths. Okay, and I think this one too, okay, this one was supposed to be a class test question. Okay, but obviously we cannot have our class test. So you can, okay, try on your own as well. Okay, so on this note, okay, thank you very much. Please don't leave, okay, for your attention and your time. God bless us all.